So welcome you all to the blockchain technology course series. So today I will discuss an important aspect of cryptography technique, which we call it as hashing, hashing function, right? Hashing function. So hashing function in a simple way, we can say it is a mathematical function like any other mathematical function. So for example, if I take a function f of x is equals to 2x, right? So here in this function I feed in the input value of x, so x is input out here, and I get the corresponding output. So this is output, let us call this as y, right? So a mathematical function takes input and gives output. So similarly, hashing function is a mathematical function, but it is a bit different as compared to the mathematical functions we have come across so far. So just to elaborate on hashing functions, what we have is so hashing function, if I explain in a simple way, a hashing function takes input and gives output of fixed size character length in form of hexadecimal numbers, right? So what does it mean? That a hashing functions like any other mathematical function takes the input and it gives a output which is of fixed length. So what is the meaning of fixed length output? So we have different types of hashing algorithms. So one such hashing algorithm that we have, we call it as SHA 256 hashing function, right? So this hashing function, it takes the input and gives the output, which in terms of binary length is 256, right? Which in terms of binary number, it is 256 bit fixed length, right? So what does it mean? That whatever input message you give to this hashing function, the output is always a fixed 256 bit length output, right? So in terms of hexadecimal numbers, we can say that it is 64 character length. It is 64 character length, where each character is of 4 bits. So when each character is of 4 bits, so in terms of binary, it is 256 bit. So this hashing function has very important characteristics, right? So I will now dive into the important characteristics of hashing function. One important characteristic of hashing function is that the hashing function is always, we say it is a one-way function. This is one very important characteristic of hashing function. Now, what is the meaning of one-way function? Let us try to understand. Again, let me come back to this example where we have a mathematical function y is equals to 2x. So here, if you observe, if I give you value of x, let us say if I say that x is equals to 2, you can very well say that corresponding value of y is 4, right? So It means if I give you value of x, you are able to provide me the value of the output, that is y. Now conversely, if I give you value of y, let us say 2, you can easily deduce that the value of x is 2, right? So that's why I say that this function y is equals to 2x, we say it is a two-way function. It is a two-way function, right? But hashing function, interestingly, is a one-way function. What does it mean? What does it mean? What is the meaning of one-way function? It means that given input, you can get the corresponding hash value or the output, but given a output, you will never be able to get back the input value. So that is why it is a one-way function. I again repeat, if I give the input data, you will be able to get the corresponding hash value, right? Which is a fixed 256-bit hash value if it is a SHA-256 hashing algorithm. But given the output, you will not be able to get back the input. So that's why we say this hashing function, it is interestingly a one-way function, right? So hashing function is a one-way function. Okay. So now I will move to another important characteristic of hashing function. Another important characteristic of hashing function which makes it very interesting, and that important characteristic of hashing function we call it as collision resistance. We call it as collision resistance, right? So I will just write a formal explanation, definition of this property, then I will explain you. So we say that a hash function, let us call it as h, is said to be collision resistant if we say that if it is infeasible to find two values x and y such that if x is not equal to y and we get hash value of x is equals to hash value of y, right? So let me explain you what it says. Again, let's take a look at this formal definition. So it says that a hash function h is said to be collision resistant if it is infeasible to find two values x and y such that x not equal to y and hash of x is equals to hash of y. So let us say that we assume x is equals to 2, right? And let us assume y is equals to 10. So let us take these two values, okay? Now what I do is I pass this value of x through hashing function. Let us say hash SHA-256, right? I pass it through this hashing function. So definitely what I will get some hash value of x, which is 256 bit. Similarly, I do the same treatment with this input y equal to 10. So I pass it through SHA 256, right? I pass it through SHA 256 and I will get some hash value of y, right? So we find that this input x and y are different. So definitely, as per collision resistant property of this hashing function, we will have hash value of x definitely not equal to hash value of y. So this collision resistant property says that it is impossible that if x and y are different, I will get hash value of both same. It is not possible, right? So that explains this the name of this property, that is collision resistance. It means two different inputs cannot collide to a same output. So this hashing function will never give you the same output for two different input. Uh, this collision resistant property is so sensitive to this hashing function in the sense that even a slight change in the input, will give a completely different hashing values, right? Now, what is the use of this hashing function? So we have a bit of idea as to what this hashing function means, but what is the use of this hashing function, right? Anyway, I forgot to tell you one important thing. If x, let us say, if x is a message, right? And we pass this message through a hashing function and we get the hash value hx, right? We call this resulting hashing value as message digest, right? Simply because this hashing function has digested, like we eat food, right? We eat lot of food, we digest it, right? So we'll eat lot of food and we extract out the limited quantity, right? So in similar analogical method, we can say that no matter how large is the message input is, this hashing function will give you a fixed output of 256 bits. So that's why we call it as message digest. The hash value we call it as message digest. Now, what is the use of this hashing function, right? So let us say you are giving an online exam. Okay, you are giving an online exam. Now, I ask the student, and let us say I am the proctor. I am the online invigilator. Now the exam time is over. Now I ask the student to submit me the answer script. So I ask the student to scan the pic of the answer script, and he must provide me the answer script, right? The scan copy of the answer script. So one way the student can provide me the answer script is, what he can do is he can scan the pic of the answer script, and he can find the hash value of the answer script, right? He can provide me the hash value of the answer script, right? And later on, when the student comes to college, right, he can what he can do is he can provide me the actual scanned copy, and what I can do is I can find the hash value of the scan copy, and I can match the scan hash value which he submitted me earlier. If both the hash values are same, it means the student is giving me the scan copy same as that of the time when he submitted me the hash value, right? Okay, so another example I will give you is, let us say nowadays we know that companies who are involved in let us say who are maybe who hold your medical data, right? right? So, such companies may hire the cloud service where they can avail the cloud service to store the medical records of a patient, right? So such organizations, they may collect the medical record from the patients, and then they can save the medical record in the cloud, right? Because you see, normally organizations, when they scale up, right, when they scale up, they normally do not hire the storage capacity, because in future they have the fear that if the company crashes, right, in that case the storage capacity may not be of any use to them, right? So normally the organizations, they hire the cloud service, right, on rental basis to store the data, right? So so let us say an organization which is involved in the medical service, providing the medical services to the customers. They store the medical report of the patient. So what they do, they hire the cloud service to store the medical data, and they store the X-ray report or blood report of the patient in the cloud. Okay, right? So what these organizations do is, they, before storing the medical records of the patients in the cloud, they store the hash value with them, right? And then they store the medical data to the cloud, right? Now in future, let us say the patient wants to retrieve the medical record, right? So he contacts the organization, right? Of course, through any app or any online service, the patient is able to access the company, request for the medical records back. So what companies do, they retrieve the medical record back from the cloud service, right? But uh, to be assured that the medical records the company which the company stored in cloud, right, are they receiving the right or the original medical record? So what they do is, they find the hash value of the retrieved medical record from the cloud, right, and they compare with the hash value which they calculated at the time of storing the medical record in the cloud. So if both the hash values are same, it means the organization has retrieved the true medical record, right? So I have given you these two examples of the application of the hashing function. So hashing functions are very important, very important to ensure, if I say in technical terms of cryptography, to ensure the integrity of the data. So this is the main application of hashing function. Means integrity of the data means to ensure that the data has not been changed by any attacker, right? Now in case of blockchain technology, what is the use of hashing function? So I will come to that now. Now in blockchain, we know blockchain, the primary use of blockchain was to allow a decentralized transaction, right? Okay, a platform where one person can send money to another person, right, without involvement of third party like any bank or anything, right? So so this transactions that has to be transmitted between sender and transmitter, or sorry, between the sender and the receiver, right? These transactions must be cryptographically signed by the sender. That I have already explained in my last lecture. So any audience who is into this particular video first time is requested to kindly refer to my previous lecture, where I explained public key cryptography, where I explained uh, public key cryptography, right? Cryptography using which we can implement the cryptographic digital signature, right? So in blockchain technology, we know that we have the transactions involved, right? Alice sends money to Bob. Okay, right? So he sends it using blockchain platform, right? So advantage of blockchain platform is that there is no third party involved, right? So you need not to reveal your identity, who you are, because when you are when you want to send the transaction using blockchain platform, you just need to have a digital wallet. Alice and Bob, they just need to have a digital wallet, and these digital wallets, they have account address, right? Account address, and each digital wallet is provided private public key pair. Okay, right? So one important point of this digital wallets are, like, if you go to a bank and if you open an account, right, definitely you have to complete your KYC, know your customer, right? So for that, when you are opening account, you should provide your PAN card number. If you are Indian, you have to provide your Aadhaar card number, your address proof, right? So all this gets connected to your account number. So when you are doing a money transaction, right, the bank will be able to know the complete identity of the money sender, correct? But when you are opening a digital wallet, right, to connect to blockchain platform, you need not to do any type of KYC, right? So you just have an account address which is not connected to any of the identity of the account holder, and you are provided with a private and public key, right? So when you go to a bank, right, and you want to do some transaction, right? For example, you want to deposit money or you want to send money to a person, right? So you go to a bank and you have a check with you. So you have to sign your check, isn't it? Because signing a check provides the authentication that you have indeed agreed to send money to some other person, means in future you cannot deny it. So with similar concept, we do in case of digital wallet, right? Suppose Alice wants to send some money to Bob, okay, right? Then Alice must have money in its digital wallet, right? So when Alice orders a transaction, right? So that transaction has some transaction details. So transaction details involves like the amount that is being sent from Alice to Bob, right? Alice to Bob, the account address of Alice and account address of the Bob, right? And it also has a timestamp. Timestamp means the time when Alice, sorry, the writing is quite poor. So we have the timestamp when Alice is sending the transaction to the Bob, right? So all these details are there. So what happens? This transaction which contains all this detail, this is cryptographically signed using the private key of the Alice, right? Okay. So using private key, let us say if I say this message or the transaction details as T, right? So T is signed by private key of the Alice, right? Right. So this this results in, we say, T dash. Okay, so T dash is the encrypted transaction message signed by Alice by its private key. Okay, so then finally this T dash is encrypted using public key of the Bob. So I will write here public key of the Bob. Okay, here private key of the Alice. Now why it is done, right? Let us say we say that we get T double dash. Okay, so what Alice is doing, Alice has decided to send some money, right, to Bob. Okay, so what Alice does, Alice signs a transaction with its own private key, right? And then let us say the resulting encrypted transaction value is T dash. Then Alice does what? Then Alice, after this, Alice encrypts this T dash with public key of Bob. Okay, so we know in case of public key cryptography, uh, if a message is encrypted with private key, then it can be decrypted with public key, its corresponding public key. In reverse direction, we can say if a message is encrypted by public key, then that message can be decrypted by its corresponding private key, right? So we have public private key pair. Now we have message T double dash, and mind you, this T double dash is obtained by encrypting T dash with the public key of the Bob. Now if one wants to obtain T dash from T double dash, then how it is possible? It is possible only by the private key of the Bob. So it means only Bob will be able to retrieve back T dash, right? So Alice basically transmits T double dash, right? So this T double dash is available to everyone, right? It is available to everyone, but only Bob will be able to retrieve back T dash, or we can say only Bob will be able to decrypt T double dash to get T dash. So Bob is able to obtain T dash by using its private key, by its using private key of Bob, right? So using private key of Bob will be able to get T dash, right? Okay, now why this is happening? Because the T dash is signed by public key of Bob, right? For that, or T dash is encrypted by public key of Bob. So the corresponding private key pair is required to decrypt this T double dash. Okay, so the corresponding key pair of public key of Bob is the private key of the Bob, which lies with only Bob, right? Private key lies with the Bob, right? Private key is not available to everyone. It lies with the individual holder of the private key, right? Now, once Bob is able to retrieve back the T dash, right, which is the encrypted value of T double dash. Now what T double dash has? T double dash has the amount that Alice has sent to Bob, right? The timestamp, okay, right? So what Bob does is now Bob uses to get T back, right? To get T back, what Bob does? Bob uses public key of Alice, right? Okay, public key of Alice. Now public key is available to everyone, so using public key of Alice, Bob will be able to retrieve T. So he will get all the information that this transaction has done by Alice, for how much amount at what time, right? Okay, so this is how the public and private key is used. Now what role hashing function plays, right? So normally Alice does not encrypts the true transaction details. So this transaction detail straight away is not encrypted. So what Alice does, what Alice does is, first of all, Alice, let us say we have this transaction T, right? This Alice finds the hash value of the transaction T first. Okay, right? So the hash value that we get, if you are using SHA-256, that hash value is 256 bit. Correct? Okay. Now, why this hash value is calculated? There are two reasons. Because this transaction details, the data message of this transaction detail can be of larger length. Okay. So to encrypt the large length data message, you need to have the key length to encrypt it should be of equal length. Okay, so let us say if my data size is of 256, let us say 254 kilobyte, right? Let us say this is the length of the transaction detail T. So to encrypt this message, which is of 1024 kilobyte, I need to have the my key length to be of 1024 kilobyte. Okay. So what we do is, instead of generating 1024 kilobyte key length, we generate 256 bit length hashing value, and that hash value of the transaction is actually encrypted by the Alice. So Alice does what? Alice takes the hash value of the transaction and then encrypts it with its private key, right? So it encrypts with private key of Alice, not the transaction. Actually, this is what it is done, and what we get is the encrypted hash value of the transaction. Okay, this is then this encrypted hash value of the transaction is then encrypted with the public key of Bob, right? Public key of Bob, and then we say, let us say we call it as HT double dash. This is what is transmitted to this is what is transmitted to Bob. So HT double dash is transmitted to Bob along with the actual message. That is, this is transmitted with the actual message, right? So interestingly, what happens when Bob receives this H double dash? Bob receives HT double dash, right? So what Bob does? Bob uses its private key, right? So Bob uses its private key, okay, and is able to get HT dash. Why? Because if you recall here, this HT dash is encrypted by public key of Bob. So definitely it can be decrypted by private key of the Bob only, right? So the Bob is able to get HT dash, right? And then Bob uses the public key of Alice, right, to get the hash value of the transaction, right? So now Bob does what? Bob has the hash value of transaction. Bob simply finds the hash value of the actual message, which is transaction T, and the Bob is able to get the hash value of T. So he matches this with this decrypted HT. If it is same, it means that the integrity of the message is maintained. That is, the message or T, which is actual message, is maintained. No one has modified it. Okay. So there are, if we observe this whole discussion, we see the two uses of hashing function in blockchain. One is that using hashing function, the length of the key that you require to encrypt the message, it becomes small, right? Okay, so next point is that you are the center of the transaction, and the receiver of the transaction using this hashing function is able to ensure that the transaction detail that has been sent is not modified by any intruder, right? So I will stop here. I thank you all for seeing this lecture. So in my next lecture, I will give you a small demonstration of how the hash value of a given message is calculated. So thank you.